Hey guys, so I'm gonna try to shoot this video on the phone, uh, trying to show you how I calibrate the machine. There are, I don't know, hundreds of ways how to calibrate a machine, and some of them they're really nice, and some of them they're really cheap, and they work. So to do this, we gotta agree on something first. So let me send this machine to my zero. Stay on the probing tab and go to my work offset 2. I should start the machine on, but I know that's my offset 1 and that's my 2. So let me just click here. You remember I fixed this bottom so it will only move on X and Y. So that's 0 on X and Y. I know I got it somewhere there because I worked on it last night. Wanted to make sure. So we got to agree on something first. The shorter you calibrate your machine, the shorter distance you use to calibrate your machine, the more mistakes you can make. And those mistakes, they're gonna start adding up. Let's say you got on a 1-inch dial indicator, you got 1,000 or a half thousands. By the time, if you got, 1/10 of a thousand, by the time you do 10 inches, you're gonna have a full thousand off on it. So let's say we're gonna build a part at a 1-inch, we're not gonna see 1/10. Tens of a thousand, I believe that's how you say it. Anyway, but on 10 inches part, you are going to see 1,000 difference. So the longer you can calibrate your machine on your full table, the better your calibration is going to be on the full machine, on the full scale. So on this case, I'm just going to show you like this. I got 1, 2, 3 blocks, so that's a full 9-inch. So you got to go by something. In this case, I got 9 inches here, and I'm gonna try to go from this end to this end and make sure whenever I touch on this end to the other side, I will be showing 9 inches on the DRO. So that means the machine is actually moving mechanically and actually showing on your DRO 9 inches. But to do that, I got this Heimer, and I wanted to see on this machine, which is not the best machine. This machine has some backlash on X-axis. I can work with it because it's not much. I believe it's a half a thousand, and this is a big old machine, so I don't care. Anyway, what I'll do, I always try, if I'm pushing my Heimer to the minus position, I'm always gonna try to push it to the minus position too. I'm saying when I'm moving, I'm trying to go minus both times on one end and on the other end of whatever I'm measuring. Hopefully you understand that. So whatever the backlash is in it, I can always see the same on my DRO. So my DRO right here, I got 9 inches, 0.4 thousandths. So that means that's what my Heimer shows. So it doesn't mean the Heimer is perfect or your dial indicator is perfect. Whatever you use, it don't matter, and I will show you in a second. As long as you calibrate it, as long as you know what you can get out of it. So right now, my Heimer is got, let's say, 4 thousandths difference on whatever it is reading. So it's not even perfect. So I got to make sure I show that same reading mechanically, see, on my blocks and on my DRO on that machine. So what I'll do, I know that I got 9.4 inches on X-axis, and I got the same blocks over there. What I'm gonna do, I'm gonna lift my C-axis gently, because I take care of that Heimer. I love it. You saw me running it on device the other day. I normally do not do that, but on some cases I do. So I'm gonna get it out of here. Come on, baby. Then I come to this machine. Let me lower. Sorry, I got you on one hand and trying to do 1,000 things. So, and I put my Heimer on the Haas, and I'm gonna mount you here on this tripod or whatever, and hopefully the battery doesn't go off on my time, or the memory in that. So I'm gonna go. Drop it a little bit. Or that is fine. So we're gonna hit on it barely. Ooh, slow down, baby. And see, I'm going to the plus position, right? So I'm gonna get close to that 0. I went too far. Let me go back. One more. We are a little bit off the 0, and we are gonna come here, and I'm gonna zero my X. So I'm gonna zero my X over there. Then I'm gonna lift my C axis. Gently lift it and go hard on it. We can break it. And then I'm gonna move to the other end. Lower her again. And then hit on the other side. Now remember, we gotta go on the minus and then come back to it on the plus. So that we went on the plus too much. And no, actually, yes, we gotta do that. Yeah, so now we gotta go on the plus. Until we hit 0. Somewhere over there. No, we are about 1 off. We are about 1 off. I can't just get it right over there. But you see here. So if I move, let's say 1, last 2. I can't just get it right. I'm trying to, but I can't get it right. I can't get it right. Say 4. It's not perfect at 0, but it's somewhere over there. So there could be 1,000 off on 9 inches. So that way, you know, the machine is pretty close. I mean, that machine over there, I know it's got backlash, and it could be maybe 1,000, somewhere like that. This one, actually, this machine has less backlash than that one there. But you see how that's really close over there. I cannot even go 1,000. I don't know. This thing is crazy. Sometimes it does, sometimes it don't. So I have to, let me reset it. Okay, that's 3,000. Let me move over there. I can't get it right. I don't. So I had to go on the plus. Yeah, I have to go on the plus. I can't just get it right there. But anyway, it's really close to the, you know, to the 1,000 difference on it. So let's say instead, see, let's say we got 1,000 difference here. You know, mistake. The machine is not right for 1,000. And we will be doing this same test on 3 inches on only one block. That 1,000 is going to start adding up. The bigger the part you put in the machine, the more the bigger the mistake is going to be on the machine. So when you're going to calibrate the machine, so make sure you can cover the most space on your table you can, either way, X and Y, and that will narrow the limit on your mistake. How you can do that if you don't have a hammer, or let's say you don't have a dial indicator. You can call a tool, let's say a tool that you think is kind of okay. Normally can be, you know, a 1/4 inch tool, a 1/2 inch tool, something. Let's say we're gonna use it like a gauge. So I'm gonna call my tool my tool 19, and I'm gonna drop my 1/4 inch my 1/4 inch over there. Gonna get close to it, and you can do the old paper. I always got a piece of paper. The paper trick, right? Hey, let's put it on 1,000 increment. So when the paper stays over there, when you move it, whatever you think, you know, you can still move it or a little bit tight. You gotta make sure it's gonna be tight on both ends. I don't want that, so that's 0 for me. You come here to your DRO, you're gonna zero your X, then come back, let's change increments, go to the other end, drop C, get close to it, not too close, don't break it now, that's really close, okay, and then we're gonna change our increment to 1,000. And on the loose side, 1,000 over there. That's on the loose side. Anyway, that's close enough. So I did from here, I mean from 0 to 9 inch on a 1/4 inch tool. So it's 1/8 on this side, 1/8 on the other side, plus the 2 pieces of paper, right? And this is what I got on the DRO. I got 9.0 262, right? That's what I got on the DRO. And let me lift this so you see. And let me put this let me call this the Pakistani way. like you gotta get it done, but and you don't have all the tools, so you got 2 pieces of 1, 2, 3 block, or 3 pieces of 1, 2, 3 blocks. You cannot get cheaper than that. And so you see that paper is around 5,000. So let's say it's 5.2, right? So around 5 or 6,000 on each side besides the tool. So we're really close, and we did it with no crazy tool, the same tool you got, your 1/4 inch tool. You can calibrate your machine. Now the longer, like I said, the longer you do it, the better it's gonna be. In this case, I gotta give it to the guys with the routers. See, sometimes you can even get a tape measure and do, like, let's say 8 feet long table. If you are able to really match your 8 feet table, most of those routers, they're gonna be more accurate than some of these machines, because once they're really accurate on that distance, when you come down to 3, 4, 5, 6 inches, they're really right there on the spot. So the longer you set it up on your table, the better your machine is gonna be, or your mistakes, they're not gonna be that big. So like you saw me doing over there, 3 1 2 3 blocks. I wish I can just put 6 1 2 3 blocks, which I do have, and I might do that. 6 1 2 3 blocks at that number, and make sure on all that full distance on my table I can achieve, 1 or 2 thousandths or half thousand or whatever. If I do that on that full distance, I know in 3 or 4 inches I won't have no mistakes. The rest is on your tool compensation. I mean, most of the time that's all you got to do. At least me, you got to work with your tool, know what, kind of test your tool a few times before you get to the point where you know what big mistakes you got. Like, see, on those cheap end mills that I use, those aluminum 3 fluid that I use, some of those tools, they're 3,000 radius, they're 2,000 off on the radius, so that's 4,000 total. So you got to be careful with them. That will set off your part really far away. So try to get that far with your full table, and the rest, do the compensation on your tool, and the parts are gonna get quite close. Never perfect, but they're gonna get quite close. At least for this cheap stuff, they will work. All right, guys, I hope you like the video and you learned something. I learn every day. Anytime I try to play like this, I learned that I got those mistakes. The other way is like everybody does on Mach 3, your axis calibration or whatever, and then you send it to a spot on your dial indicator. But they get good, but not that good, because just a little bit here, just a little bit there will create a lot of problem on a full table. All right, guys, well, thank you so much for watching, and I will see you in the next one. Thank you.